Alright, Navy Corps Steelwork Volume 2, Chapter 2, Part 2. Joining and installing sheet metal dug. After the sheet metal has been cut and formed, it has been joined together. Most sheet metal seams are locked and riveted, but some will be joined torch brazing and soldering. Lock seams are made primarily with the forming process already begun. Figure 280 shows a wire notching cylindrical layout. Torch brazing soldering discussed in Steelwork Volume 1, Chapter 6 section deals with only joining sheet metal seams by either metal screw or rivets. Metal screws. Different type of the metal screws are available to sheet metal, but the most common type of the machine with the machine's core normally made of brass or steel, with which have either flat head or round head, are identified with the number size of the threads per inch length. For example, 6x32, which 1 inch screw indicates the number 6 screw with the 32 threads per inch 1 inch length. Self-tapping sheet metal screws are another type of the common type of the screws. Screws with the type of galvanized identified by their number, size, length. The screws are threaded as driven in Figure 281. The name implies thread-cutting screws are different. Self-tapping screws, they are actually cut threads to metal, but they are hardened and used for the fast and non-ferrous metals to join heavy gauge sheets. Alright, shows a self-tapping sheet metal screws. You have the type slotted pan head. It's a Phillips head and pan head, high thread, and tappets. Now on the thread cutting screws, you see a flexible type 6 hex screw, a type F Phillips round head, a type BF Phillips round head, a type L Phillips round head, a type B's a type B slotted round head, type B Phillips round head. And Figure 283 drive screws, type U drive screw, type 21 drive screw. Drive screws are figured in 283 are simply hammered and drilled with a punch hole with the proper side of the permanent fitting fastenings. Alright, rivets are variable in many different material sizes and type. The rivets made of steel, copper, brass, and aluminum are widely used. Rivets should be with the same material sheet metal as they are joined. Tinners and rivets are kind of shown in Figure 284. You have the sheet metal work any other form of the type of rivet. Tinner rivets are various sizes from 8-ounce rivet to 16-pound rivet. Size signifies a weight of 1,000 rivets. 1,000 rivets weighs 8 ounces. Each rivet is called as an 8-ounce rivet. As weight per 1,000 rivets increase, the diameter and length of the rivets also increase. For example, 8-ounce rivet has a diameter of 89 thousandths of an inch, length of 5/32 of an inch, while the 12-pound rivet has a diameter of 259 thousandths of an inch, and length of 1/2 inch. For special job of the wire fastening, several layers of metal together. Special rivets with extra long shanks are used. Fable 2.1 is a guide for selecting rivet the proper size in sheet metal work. 2.1 Figure 284 shows tinner rivets. As they go from 8 ounces to 12 pounds. 2.1 guide selecting rivets for sheet metal work. Have gauge 26, rivet size 1, 24, rivet size 2, 22, rivet size 2.5, 20 gauge sheet metal, rivet size 3, 20 gauge sheet metal 18, 3.5 pounds rivet, gauge sheet metal 16, 4-pound rivet. When you're joining sheet metal is greater than two thicknesses, remember the shank of the rivet that should extend 1.5 times the diameter of the rivet. This will give you adequate metal to form the head. Before spacing and given the blueprint and drawing the work from, the spacing is not given in the space of the rivet according to the conditions. Seams must withstand, for example, the seam must be watertight. It must be more riveted to inch than required by seam. It does not have the watertight. No matter how far apart the rivets are, there must be the distance of 2.5 times the rivet diameter between the rivets and the edge of the sheet. This distance is measured in the center of the rivet holes to the edge of the sheet. Alright, and this shows you a pair of hand punches with a punching lever gauge, punch holder, punch, die, throat, and center point. And then 286 shows a drawing upset, heading of a rivet. After you've determined the size and spacing of the rivets, mark the location center of the rivet hole and make the holes on the punching of the drill if the holes are located near the edge of the sheet. A hand punch similar to one shown in Figure 285 can be used to punch holes. If the holes are farther away to edge, you can use the deep thread punch, either hand-operated, power-driven, or you can drill the holes. The hole must be slightly larger than the diameter of the rivet to provide a slight clearance. Riveting involves the operation drawing upset heading and a rivet is set and the riveting hammer used to perform these operations method the rivet sheeting metal files. Select the rivet side of the hole slightly larger than the diameter of the rivet. Insert the rivet in the hole's rest. The sheets to be joined on a stake or a solid bench top with a riveted head against the stake of the bench top. 3. Draw the sheets together, placing the deep hole of the rivet set over the rivet, striking the head of the set with a rivet hammer, using a light hammer with small rivets, a heavier hammer with larger rivets. For when the sheets have been properly drawn together, we remove the rivet set, strike with the end of the rivet lightly with the riveting hammer, upset with the end of the rivet, do not strike too hard with the blow, as with the distort the metal around with the rivet hole. 5. Place a hand-dyed dish part over the rivet set of the upset of the rivet form of the head. 1 or 2 hammer blows on the head of the rivet set will be enough to form a head on the rivet. Figure 287 of the correct and incorrect riveting. A correct drawing upset of the head rivet is shown in figure top part 287. The lower part of the figure shows the result incorrect riveting. So you have the drawing, your upset, and your heading for the correct riveting, and your troubles with the head too small, riveting not drawn, and sheets are not drawn. In addition to sheet metals, rivets are top the pop-up of the rivet shown in figure 288. The pop-up rivet is high strength with precision-made hollow rivets assembled on a solid mandrel forms an integral part of the rivet, especially used for the line fastening or the limited no access to the rear side of the work. So here we have the pop-up rivets, close-in hollow core type dome head, solid core countersunk head, open-end document type, dome type, and countersunk head. Pop-it rivets provide simple versatility, simple and easy to use with complicated installation. Expensive equipment and skill of the operators are not required. Just drill a hole, insert and set of the pop rivet from the same side. High riveting quality, strength, easily and quickly accomplished. 2 basic designs of pop rivets are used with the close-in, opening them with the close-in type filled with need with the blind rivet seal with they are set with a gas tight, liquid tight, and like open-ended type. They are installed and set from the same side. Add the rivet side and with a high degree of the radial expansion of the generator with the riveted body providing effective hole filling qualities. The open type of the pop of the rivet resembles a hollow rivet with the outside because of the mandrel head stays in the rivet. The mandrel stem seals to a certain degree, but it is not liquid tight. Figure 289 shows the 2 tools used for setting poppet rivet. The tools are lightweight, very easily used. For example, when using a small hand tool, you need only insert the mandrel of the rivet into the nose piece, squeeze the handle, and use 3 times, and rivet is set. To operate scissors type, the tool fully extend with a lever, linkage, and gas gate-like mechanism. Insert the rivet mandrel into the nose piece of the tool. Insert the rivet into the piece being riveted. Apply firm pressure to the tool. Ensure the nose piece remains in close contact with the rivet head. Closing lever linkage retracts the grip mechanism with the draws. The mandrel and the rivet set with the mandrel head breaks. So here we have the 2 pop-up rivet tools. Before inserting another rivet in the tool, be sure that the broken mandrel has been ejected from the tool. This can be done by fully extending the lever linkage, allowing the mandrel to fall clear. The scissors expandable type of the tool is unique because it can reach hard to get areas and you can set the rivet at ease. The tool is particularly useful for insulation, ventilation, ducting. Riveted seams. Riveted seams are used for joining metal that have numerous applications. Figure 290 shows the pattern of the 1-2 pieces joined and lap riveted note the cross-section unfinished seam. 290 shows the pattern riveted lap seam. 291 shows a riveted seam with its half of the riveted corner seam. Figure 291 shows the pattern construction lap, the riveted corner seam, the view A with the pattern for one piece, view B with the other, note with the cross section through with the completed seam. For use made lap with the riveted seam joint round pipe section sheet metal duct systems. Alright, with the advent of the high-tech equipment such as the other specialized electronic equipment, air conditioning systems, and incorporated more than every of the naval construction force construction project. Many of the structures designed long life usage intended with temporary building, short-term use. Also, some of the advanced base functional components which incorporate heating, ventilation, air conditioning systems. With facility done, heating and ventilation, air conditioning systems require close coordination between ratings and air conditioning, air handling, heating units normally installed by utilities man electrical connections are accomplished by construction and electrician. These items must be installed before the ductwork installation phase begins. Steelworker must also coordinate the builder assigned to the project to ensure that all openings in the walls and floors are sufficient to accommodate duct, diffusers, and vents. Sheet metal, the heating, ventilation, air conditioning systems require knowledgeable work to fabricate, install various ducts, and fittings need to complete heating, ventilation, air conditioning system. Steelworker and very versatile because the most difficult part of sheet metal work is essential to do of the product that has not been built in the shop instead of on the site at a later time. All the variable problems occur during the installation process can be covered for however, this section will cover some of the different hanging connection systems used by sheet metal work and the type of the connection system that depends on whether the duct system is installed in size, how many obstructions there are, and also what type of structures the system is hanging from and connected to. Shop procedures. Small sheet metal shop of the Navy Construction Force or in Public Works Department are normally tasked with a single fabrication job of the Navy Construction Force project or small repairs projects. These shops usually employ a small number of steel workers as part of the multi-shop environment. A senior steel worker assigned to the shop is tasked with plan development and estimating material layout. Steel workers may be the utmost fittings of the shop of the responsible for stockpiling, pattern tracing on standards. Fittings using sheet metal duct systems. Note you should fabricate the entire job at the shop rather than deliver it incomplete to the shop site. Shop drawings. A shop drawing plan view of the elevation view of the fitting duct with the other object of the drawing, either with a freehand sketch method using drafting instrument, may be useful to get assistance from engineers and complex duct systems or fittings. One better method is to draw a complete set of standard fittings that add the required dimensions of the fit job. Dimensions shown in the view shop drawing and the finished drawing of the ones half finished with dimensions have been determined 1/2 inch must have be added to each end of the obtained overall size of the pattern. Dimension produces a cut side of the dimension type of the material of the gauge number, the type of the seam that may be added to the shop drawing. If desired, usually specify the drawings on the pattern sheets. Duct material, metal sheets, wire, band iron, angle iron are most widely used. The material sheet metal fabrication type of the metal sheets are plain flat sheets, rib sheets, and corrugated sheets. These sheets are made of such materials: black iron, galvanized iron, tin plate, copper, aluminum, stainless steel, or metal. Galvanized and black iron sheets are most commonly used in material and sheet metal work. Thickness sheet is designated by a series of numbers called gauges. From the iron sheet and iron and steel sheets are designated U.S. standard gauge, which is accepted in standards in the United States. Reinforcement and support. Recommended gauge thickness of the sheet metal used in the standard ventilation air conditioning system. Normal pressure velocities shown in figure table 2.2. Where special rigidity, stiffness, or required ducts should be constructed metal 2 gauges heavier than those given in the table. All insulated ducts in 18 inches or greater and flat side should be cross-broken and shown in figure 292. Cross-breaking means omitted if the duct is installed with an improved rigid type installation. Sheet metal 2 gauges heavier are used. Maximum length. Any section of the ductwork will not exceed 7 feet 10 inches. The measurement allows individual sections to be fabricated for an 8-foot sheet of metal within 2 inches of allowance of the connection tabs. If the length of 7 foot 10 inches are considerable too long for a specific job, it is recommended the duct system can be constructed with sections of 3 foot and 9 inch multiples. Many duct systems run into the unplanned obstructions, particularly with the renovation work such as electrical connection, wiring, and structural members. Alright, this shows a cross-broken flat surface, X. Here, table 2 shows recommended gauge of sheet metal duct construction. And piping system, the obstruction must be avoided. Fabricating the duct system around with the obstacle. Do not run obstructions from duct system because it creates turbulence. Reduce the efficiency of the duct. With the obstruction and the electrical obstruction, you should ensure all power off and safety checked. When the running of the duct through an obstruction is absolutely unavoidable, turbulence can be reduced by enclosing the obstruction in a streamlined collar. Flexible connections. Most duct systems together connected either heating cooling systems are generally electrical motor driven to move air through duct system. They are all inlet outlet duct connections to all fans. Other equipment create vibration should be made in heavy canvas as shown in figure 294. 293 shows an easement around obstruction in the ducts. The most common method of making connections between ducts and fittings is method combining 2 S-slips and 2 drive slips. Figure 295. Figure 294 shows flexible duct Connection 1, using a cloth, a connector. Do not pull cloth to tight. Methods of making the connection, and then the S-slips, slips in first place to opposite edge of the section fitting to join. The S-slips are applied with the widest dimension from the duct. Figure 296 second fitting are inserted within the slip of the section held together by inserting drive slips around the opposite edge. Figure 297. After the drive slip is driven home, they are locked in place by bending the edge of the drive slip over the corner of the S-clips closer to the corner. Leak the drive slip shown in place, shown figure 289, complete with the shown in 299. Hanging duct from purlings or beams. Most of the ducts of the steelworker install the modified repair pre-engineered building. Repairs more permanent type of the duct. Buildings under the bracket base housing. Most common installation method of hanging ducts or purlins, beams, or hidden area. Figure 295 shows your your method of connecting ducts to the S-slip and the drive slip. 296 shows placing S-slip in the S for an S-drive connection. Inserting a drive slip. Bending the drive slip to complete the joint. The roof or below the ceiling. Figure 2-100 shows one of the system running parallel to the structural member. The system requires the angle be installed between the beams so the hanger straps can be installed on both sides of the duct. Normally 2 inch by 2 inch by 1/8 of an inch angle. Alright, 299 shows the completed S and drive connections. The S-slip. And then the drive slip. End of the drive slip bent over the lock joint. Figure 2-100 duct running parallel to purlin beams. Efficient height with the duct is very large and small. Large angle may be required. Straps that are used with the hangers may be fabricated 1/8 of an inch plate. Normally installation 1 inch by 1 IS inch strap will suffice. All straps must be connected to the ductwork with a sheet metal screw. Sheet metal screws on all government work. It is required that the screws be placed 1 1/4 inch from all edges. Those gem figures shown as the duct seam to the angle rails, that all angles be a bolt and tack welded to purlins or beams. Strap hangers may be hung directly to purlin beams of the duct, running transversely across the purlins or beams as shown figure 2-100. However, the straps hangers must be twisted to turn 90 degrees. On a flange to beam purlin. Again, the standard 7 foot, 10 inches maximum span required hangers apply. Also, hanger screws standards will apply. The hanger spans may be shortened to fit job requirements. For heavier, larger systems, installation similar to shown in figure 2-102 may be required. System hung entirely angle rails. The straps are fabricated in one piece. The system is far innate by the knees, looking normally used when duct system is exposed. Installing a duct system build-up steel roof, figure 2-103, accomplished by hanging the duct system. All thread bolts and 2 by 2 by 1/8 of an inch angle. All thread bolts protrude through the steel ducting as bolt at the top of the large washer and bolt, which extends both alongside of the duct of the 2 inch by 2 inch angles, which also bolted for the under angle. System allows for the adjustment of the height. All notice so that all of the add bolt extend to the top of the flat with the apex steel of the roof decking. This is required because of the connecting the all thread bolt with the bottom valley with the steel deck will reduce structural strength of the decking and may also cause water leaks. Fiberglass duct system through naval construction. Fiberglass become the common job site that has advantage of adding insulating value. Fabrication and handling, as well as the installation, making it very trafficable. Handling abuse for restricted. Alright, figure 2-102 shows the duct system strap hangers with angle rails, transverse purlity. Alright, we have 1 inch by 1/8 of an inch strap. 1/5 inch by 2 inch angle. 3/8 of an inch or less length of width angle. 2 by 2 by 3/16 of an inch length. Your purlin determined by the duct and elevation as required. And duct characteristics: fiberglass duct with manufacturer mold of the fiberglass sheath covered with a thin film coating aluminum. Although vinyl and plastic coatings are sometimes used, the Navy construction force are primarily concerned with aluminum coated duct because it is fabricated glass fiber that is inherently insulated, therefore where insulation is a requirement. Fiberglass ducts can be molded into various shapes with special applications. Desired shapes can be ordered to manufacture stock of the Navy Control Force. For all but special purpose, the duct is supplied with a flat form board of V-grooves cut into the inner surface holding the fabricated rectangular section. Figure 104, view A, the ends of the board is molded with the rectangular square duct form of the two sections same size, fit together into the ship lap joint. Figure 104, view C, this joint ensure the tight connection coupled to positive alignment. Figure 103, show the duct and solve the build-up steel roof. Show the 3 8-inch all threaded bolts. Alright, figure 104, show fabricating rectangular square fiberglass duct from board. Cut grooves in the duct board, overlapping and a heat seal, adhesive, tape, and it's then stapled along the duct, forming the duct and the ship lap section's top. Of extreme importance, selection of the proper board size fabricated the duct before cutting and grooving in all applications. Inside diameter of the duct is determined in the factor of the board size to determine the board size. Figure 2.3 show the duct board length selection chart. Note, with a heating system, use the fiberglass duct restricted adhesive used to affix the protective outer coating to the fiberglass ship with a specification ensure that it will not fail to expose the heat over 250 degrees. Fabrication. Fabricate rectangular square duct. You must first measure the duct board or quote accurately. Next, groove that must be cut. Ensure that they are properly location cut straight to cover all the board's folds. Create desired rectangular square shape. Cutting the board, you will need to leave the overlapping top of the pulled, tighten, staple figure 104 view A, taped as the other, as then applied to joints, heated seal figure 104 view B, joints between the section fabricated, pulling the ship lap end of the section together, finish stapling, taping, and heat sealing the joint figure 104 view C. Alright, installation vary. Nature of fiberglass duct requires that it be supported 1 inch by 1/16 inch galvanized steel strap hanger that must be supplied with a fabricated to fit with the duct precisely. Will the duct be rectangular, square, or round? Rectangular square ducts up to 24 inches in span can be supported on an 8-foot center. Ducts larger than 24 inches must be supported on 4-foot centers. For rounder ducts, support must be not less than 6-foot centers. Safety precautions. Some of the safety precautions are applicable to sheet metal tools equipment that have been mentioned throughout this chapter. However, there are a few additional precautions should be carefully observed when we are working with sheet metal. 1. Sheet metal can cause serious cuts. Handle it with care. Wear steel reinforced gloves whenever feasible. Treat every cut immediately, no matter how minor. 3. Remove all burrs of the metal sheet before attempting to work on it further. 4. Use a brush to clean the work area. Never brush metal with your hands. Use tools that are sharp. Keep your hands clear of the blade on all square shears. 7. A serious painful foot injury will result in your foot if under the foot pedal of the square shears when cut is made. 8. Do not run your hand over the surface of the sheet metal that has been cut or drilled. Painful cuts can be received from the burrs. 9. Get help with large pieces of sheet metal are being cut. Keep your helper well clear of the shears when you're making the cut. 10. Keep your hands and fingers clear of the rotating parts of forming machines. 11. Place scrap pieces of sheet metal in the scrap box. 12. Will always remember to keep clean shop. Good housekeeping is the key to a safe shop. And 13. Do not use tools that are not in first-class condition. Hammerheads loose on the handle, chisels with mushroom heads, power tools with guards removed, and so forth. 14. Wear goggles when in the shop. And that was Chapter 2, Part 2. Chapter 3. Structural steel terms, layout, fabrication of steel and pipe.